Now, the next topic is uniformly accelerated motion. Now, you know what is an accelerated motion is. Accelerated motion, in which the velocity of the object is changing. That is an accelerated motion. Now, since suppose in a non-uniform motion of an object, the velocity of an object is different at different instant. That is, the velocity of object keeps on changing with time. Such motion is said to be an accelerated motion, means the velocity is changing with time. Now, consider in an accelerated motion only, if the change in velocity of object in each unit of time is constant, that is, the object is said to be moving with constant acceleration, and such a motion is called uniformly accelerated motion. So, this will be uniformly accelerated motion, in which though the velocity of an object is changing, but that change is constant with respect to time. That is uniformly accelerated motion. Now, if the change in velocity in each time is not constant, the object is said to be moving with variable acceleration. Like if the change of velocity is not constant, then such a motion is called that is understood also is non-uniformly accelerated motion, and such a motion is called non-uniformly accelerated motion. Now, basically what is an acceleration is? Acceleration is the change in velocity upon the time interval. Acceleration of an object in motion is defined as the ratio of change in velocity and the corresponding time taken by the, basically acceleration is change in velocity upon time taken. Now, acceleration is a vector quantity that is represented as A, like this is a vector quantity. Now, we take acceleration as positive if the velocity is increasing and negative if the velocity is decreasing. The negative acceleration is also called retardation, or that is also known as deceleration. Now, let us discuss average acceleration also. So, average acceleration. Now, average acceleration is equals to the total change in velocity. So, that will represent the total change in velocity. Total change in velocity upon the total time taken. So, that is known as the average acceleration. Now, again once more, the instantaneous acceleration. Instantaneous acceleration. Now, instantaneous acceleration is like the acceleration of an object in a given instant of time. That is called an instantaneous acceleration. Now, see, average acceleration, again here we can write average acceleration like AVG, that will be equals to delta V, it is a vector quantity, by delta t, delta V by delta t. Now, the instantaneous acceleration, again in this case we have to take that delta t tends to 0, means that the time interval is actually very small in this. So, acceleration is given as limit in which you take delta t tends to 0, which is equals to delta V by delta t, delta V by delta t, and this is also written as dV by dt. So, and also we know that V is, as we have already discussed, is dx by dt. Therefore, so A will be what? A is actually d by dt of dx by dt. So, this is equals to d 2x by dt2. Now, the instantaneous acceleration of an object is also equals to the second time derivative of the position of object at a given instant. So, means if a position is given, you have to differentiate with respect to time, then again you have to differentiate again, means double differentiation with respect to time. Okay. So, now from the like velocity time graph, okay. Now, see, let's discuss some graph. So, velocity time graph, we know that this is a uniform velocity and this is moving accelerated body from acceleration. Now, if we draw a graph suppose like this, then this will have a negative acceleration, this will be the retardation. So, this will be what? Retardation, this is acceleration and this is constant velocity. These are the graphs of velocity time graph. Okay. So, now I will be giving you the formulas. I will showing you the formulas, which is known as the equations of motion. So, first equation of motion is v is equals to u plus at. V is equals to u plus at. This is the first equation of motion. Second equation of motion is s is equals to u t plus half at square. This is second equation of motion. And third equation of motion is v square minus u square equals to as, where v, this v is the final velocity, here v is the final velocity, this is initial velocity, acceleration time, s stands for displacement. Here s is the displacement. Yeah, and there is one more formula like distance travelled in the nth second of uniformly accelerated motion. Since our topic is accelerated motion, uniformly accelerated motion. So, this is the distance travelled for the nth second. Now, the formula is the distance for that particular second, nth second, dn is equals to u plus a by 2, this is 2n minus 1. So, this is for the nth second, u plus dn is equals to u plus a by 2, 2n minus 1. Okay, now we will be deriving these formulas by the calculus method, the equations of motion formulas by calculation method. Now, consider an object moving in a straight line, moving with an acceleration a. Okay, let v1 and v2 be the velocity at timing t1 and t2 respectively. So, timing of v1 is t1, timing of v2 let it be at t2. Okay. Now, velocity time relation means the first equation of motion. Let at any instant t, considering at any instant t, v be the velocity of object, v be the velocity of object and dv be the change in the velocity of object in time interval dt. So, basically we can write acceleration as dv by dt that is the acceleration. Now, you cross multiply, this will be a into dt equals dv, or you can write dv equals a dot dt, a dot dt. Now, integrating it with the conditions of motion, that is when the time changes from t1 to t2, the velocity changes from v1 to v2. So, integrating it, we can take a common directly. So, integrating it, when this is v1 to v2, the time is t1 to t2. Okay, so integrating this will be v2 minus v1 directly, v2 minus v1, which is equals to a. Again this is dt, on integrating this will become t, so that will be t2 minus t1, t2 minus t1. Now this, as you can see, this equation is same as the equation which we had given in the, which we had like shown, like v equals to u plus at. See, if the velocity of object at time, now you consider t1, time t1 is 0, so let the, this is the initial velocity u, and at t2 means at t, let the final velocity be v. So this equation will be reduced to, this is actually v minus u equals at. So this will be reduced to v equals u plus a times of t minus 0. This is same as v equals u plus at. This is the first equation. Now second equation of motion. Now consider an object moving in a straight line with uniform acceleration a. Let at any instant t dx be the displacement of the object in time interval dt, then the instantaneous velocity. Or we can simply start like this, instantaneous velocity v is given as dx by dt. You cross multiply, you get dx equals to v dot dt. Okay, now substituting the value of v, v is what, u plus at. So dx will be, that dx will be v is u plus at dot dt. Okay, this is the equation. Now integrating the above relation means this relation above, oh sorry, this is below or whatever, this integrating this relation within the condition of motion, that is when time changes from 0 to t, the displacement changes from, let it be x0, we take the initial position as x0 or x0 to x. So integrating this dx, this is x0 to x, this is equals to 0 to t, which becomes u plus at dot dt. Now continuing with the integration, see this thing. Okay, now you can write it like this. Integration of x0 x dx. So this is equals to u integration 0 to t dt plus a integration 0 to t dot dt. Now see, okay, 0 to x dx, actually this was the equation, 0 to t u dot dt, this is 0 to t u dt, and this is a, we have taken a common, t dt multiplication 0 to t. Okay, so now we will start the integration. So this will become x, dx integrated will become x, this is from x0 to x, this is u, this will become t only, u, this is t, 0 to t plus a, this will become t square by 2, t square by 2, again 0 t. So this will be x minus x0 equals, this is ut plus, this becomes, taking 1 by 2 common, half at square. See, I haven't done t minus 0 because that will be just ut minus 0 whole thing. Similarly, this will be at square minus 0 whole thing. So I have just removed that. So this is what, x is equals to x0 plus ut plus half at square. Now this is same as, now see, x is what the displacement. So s represent displacement. S is ut plus half at square. If the condition is that x naught is 0, means the object started from the origin. So it is same equation. Now the velocity displacement relation, or the third equation of motion. Now consider the particle moving in a straight line with initial velocity u and the uniform acceleration a. Or simply we write a is equals to dv by dt. So this is a. We can write this as dv by dx into dx by dt. It won't make any change. But we know that what is dx by dt? Dx by dt is v. So this is dv by dx into dx by dt. This thing is v. Now cross multiplying a dot dx equals v dot dv. Now we know that u is the initial velocity, v is the final velocity of object at position given by displacement x naught and x. So x naught is the position when the velocity was u, v is the position when the velocity was, x is the position when the velocity was v. Now integrating this expression within the conditions of motion. Now integrating x naught to x, a dot dx equals integrating u to v, v dot dv. So this will become x, a is common, dx will become x. So this will be a, this is x, x naught x, okay. V dot dv will become v square by 2 integrating u v. Now these are the limits. Now the equation is, this is a x minus x naught equals, this is v square by 2 minus u square by 2. Okay. Now again cross multiplying, this will be v square minus u square, 2 goes over here, this is 2a x minus x naught. Now putting x minus x naught as s, so this is v square minus u square equals 2as, which is the displacement, which is the third equation of motion. So example, a tennis ball is dropped onto the top of a floor from a height of 4 meter. Now height is 4 meter. It rebounds to a height of 3 meter. Means after dropping, it is rebounding to a height of 3 meter. If the ball was in contact with the floor for 0.01 second, what is the average acceleration during the contact? So now h1 is here, h1 is 4 meter. h1 is 4 meter. So 4 meter is the height from which the ball is dropped. Okay. And delta t, the time of contact is 0.010 seconds. Okay. Now let and you can take h2 as 3 meter. Now 3 meter is the height it goes up after rebounding. Now let v1 with the velocity of the ball, v1 is the velocity of the ball acting downward, okay, acting downward just before striking the floor, and v2 we take the velocity of the ball acting upward just after striking the floor. Okay. So the change in velocity of the ball in time delta t will be, change in velocity will be velocity. Change in velocity will be, see, what is final is v2 and initial change is final minus initial. So downward and upward. So that will be V2 minus of minus V1. Why minus of minus V1? Because one is going upward, downward. Basically, they are relatively opposite to each other. So if we take one sign as positive, the other has to be negative. So this is V2 plus V1. V2 plus V1. Now the acceleration is given as, acceleration will be the change in velocity upon time interval. We have calculated change in velocity, which is V2 plus V1 upon that delta t. Now what we have to do is that we have to find that V1 and V2. Now when the body falls from a height h1, means height h1 is 4 meter. When the body falls from a height of 4 meter, by using the third law of equation, third equation of motion, v square equals u square plus 2as. Now we know that u was 0 and a is what? A you can take g. So this is v square equals 0 plus 2 g h1 or v, and this is actually v1, yeah, take this as v1, this is equals to under root of 2 g h1. Okay. Now after striking the flow, moving up, applying the same equation of motion, this will be, now see, v square equals u square plus 2s, third equation of motion. Now we have to substitute the value. See, what was the, see, when it reaches the maximum height, because it is starting from the ground, going up, reaches the maximum height, that final velocity will be 0, equals, now v2 is that velocity with which it was going up. To take this as v2 square, v2 is same, we are talking about this v2, it's going up. Now g is negative, this is minus 2 g h2, h2 is 3 meter. Basically this will, again if you take it to that side, the sign will change. So v2 square is 2 g h2 or v2 is under root of 2 g h2. Now substituting the values, acceleration in this equation, under root of 2 g h2 plus under root of 2 g h1, sorry 1 upon delta t. Now I am substituting the values. This is under root of 2 into 9.8 into 3 plus under root of 2 into 9.8 into 4 upon 0.01. So this will be your calculation. On solving this, your answer will be 1652 meter per second square. This will be your answer. Okay. Our next example. Now see, a ball thrown vertically upward with a speed of 19.6 meter per second. Now this is the speed from the top of the tower. So basically from top of a tower, it is thrown at 19.6 meter per second but in upward direction. Returns to earth in 6 seconds. Find the height of the tower. Now you have to find the height of the tower. See, taking the vertical downward motion of the ball as positive. So from the point of projection up to the ground, so we are taking vertical motion as negative. Sorry, vertical motion as positive. Okay, taking vertical motion positive Vertical means vertically downward motion. I'm sorry. Taking vertically downward motion as positive. So what will be u? Taking u as initial velocity will be 19.6 meter per second. Why? Sorry, per second. Why? Because this is thrown upward. Acceleration is downward, so 9.8 meter per second square. Acceleration is downward. How much time it has taken? It has taken t as 6 seconds. Total time is 6 seconds. Now using the second equation of motion, S is equals to ut plus half, you can write at square or gt square, whatever. I am writing at square. So u is how much? Minus 19.6 times 6 into 6 plus half, what is a? 9.8, and what is t? T is again 6, 6 square. Okay. Now you solve this, you directly get the height of the tower, 58.8 meter. So moving on to our next example. Okay, a body travels a distance of 20 meter in the 7th second. Now this is for like the nth second, and if you remember the formula, nth second formula was dn is u plus a by 2, 2n minus 1. Like distance travel in the nth second is initial velocity plus a by 2, 2n minus 1. Okay, so distance of 20 meter in the 7th second and 24 meter in the 9th second. Okay, so how much distance shall it travel in the 15th second? So we have to find for the 15th second. So first of all, just write whatever is given to us. See, we know the formula, dn is u plus a by 2, 2n minus 1. Okay, now d7 is given to us. D7 is 20 meter. So d7, you can write d7 equals u plus a by 2, 2n minus 1. Okay, so what we will take is that we have to find u and a in this. We have to find initial velocity and the acceleration, u and a. Now it's clear, we have two variables, we need two equations. So first equation is d7 is u plus a by 2, 2n minus 1. What is this d7? So it's 20 meter in 7 seconds. So 20 equals u plus a by 2. Substituting this as 7. 2 into 7 is 14 minus 1, 13. Okay. So this becomes 20 equals u plus 13 a by 2. Now second equation will be obtained from 24 meter in 9th second. So d9 equals u plus a by 2. Now 2 into 9 is 18 minus 1, 17. So 17. So this becomes, what is d9? d9 was 24 meter. So this will be 24 equals u plus 17 a by 2. Now this is equation 1, this is equation 2. Now solving these two, like subtracting second from 1, u and u will get cancelled. So you get, minusing these two, you get 4 equals 2a, or a equals 2 meter per second square. Now we have a, we can substitute a in any one of this, you can get u. So by substituting a in this, which is 2, so 20 equals u plus 13 into 2 by 2, 2 get cancelled. So basically u is 20 minus 13, which is 7 meter per second. Now we have the value of u and a. So now the question is, it travels in 15 seconds. How much it travels in 15 seconds? So in 15 seconds, using the formula d15 equals u plus a by 2 into 2 into 15 minus 1. 2 and minus 1, and is 15 over here. So this is 7 plus a was 2, so 2 by 2. This is 30 minus 1, this is 29. 2 cancel. 7 plus 29 is 36 meter. So now the next example. From a top of a tower, 100 meter in height. Okay, 100 meter in height. The tower is 100 meter in height. A ball is dropped, and at the same time, another ball is projected vertically upward from the ground. So from the ground, another ball is projected vertically upward with a velocity of 25 meter per second. Find when and where the two balls will meet. So you have to find the distance. You can find it from above or below, like from the top of the tower or from the ground, as well as at what time will they meet. Okay. First of all, let's draw the towers. Now see, take this diagram. Take this as tower. This is A, this is B. B is considering as the ground level. Okay. One ball is dropped downward, another upward, thrown upward with a velocity of, suppose, whatever. No, 25 meter per second. And let C be the point of their meeting.